What is OpenVINO? OpenVINO is Intel's toolkit for running AI models efficiently on Intel hardware like CPUs, GPUs, and NPUs. It optimizes models, often converting them to a special format called AR, intermediate representation, so they use less memory and run faster than the original versions while keeping good accuracy. For large language models, OpenVINO works with tools like Optimum Intel. This is the bridge between Hugging Face and OpenVINO. You use it to download a model like Llama 3, Mistral, or Qwen3-Coder and convert it into the OpenVINO format. NSCF, Neural Network Compression Framework. This is the shrinker. It works inside Optimum Intel to perform quantization. For example, converting a 60 gigabyte model into a 4 gigabyte int4 model. This allows the model to run on standard consumer laptops and use much less RAM. And OpenVINO model server, OVMC. This is the engine. It takes the optimized model and hosts it as a live web service, which we will see. These tools let you run models through an OpenAI compatible API, so apps and editors can use them easily. Why we use OpenVINO? We run models like Qwen3-Coder locally instead of using cloud APIs. OpenVINO helps by providing fast performance on Intel GPUs, smooth and efficient AI interface on Intel Arc and integrated graphics. Smaller models, int for quantization, uses less memory so large models can run on limited hardware. Easy serving with OVMC. One server exposes standard API that tools can connect to. Privacy and offline use. Everything runs on your machine. No data is sent to the cloud. The RAM of my HP Omnibook is 32 gigabytes. When I run this application, it uses only 16 gigabytes of VRAM. This can be seen in Task Manager and the performance in GPU, where the shared GPU memory shows about 16 gigabytes, and this was before the update. I checked my driver version in Device Manager, and it was 6973. I read that in version 6974 and above, they introduced the shared GPU memory override feature. The feature we are looking for is called shared GPU memory override. Intel introduced this specifically to address the exact problem we are having. Local AI models needing more than the standard 60% VRAM cap. On a 32 gigabyte system, this feature can let you allocate up to 87% of your RAM, which is about 27 gigabytes, to the GPU. If we open the Intel Graphics application, you will not find an option to override it. Note that this is after the update, and the one before was considerably different. Updated, I navigated to the Intel Arc graphics driver page. I downloaded the driver and installed the update. And after the update, Device Manager shows version 8531, which is the version I installed. So after that, when I opened the Intel Graphics software and navigated to the Graphics tab, I saw the option to extend the memory up to 27.5 gigabytes, and I enabled it. So after the update, I saw the shared GPU memory showing 27.1 gigabyte in Task Manager on the shared GPU. Flip starts OpenVINO Model Server (OVMC) as a local LLM HTTP server for tools that use the OpenAI compatible v3 API. OVMC is Intel's model server. It loads an OpenVINO exported model and exposes REST endpoints for text generation, including chat style usage when configured for LLMs. Host read runs it with task text generation, and a fixed REST port. So let's use the v3 base path on that port. The script doesn't download OVMC. It expects folder named OVMC next to the batch file. So we have to download it ourselves. This will be covered soon. You can see that there is a folder starting Qwen under the model folder, like Qwen3-Coder 30B A 3B instruct int4. OpenVINO model server runs models through the OpenVINO runtime, which expects models in OpenVINO ER format, usually OpenVINO model XML. It's a network description plus bin weight files. This is because the format is optimized for Intel stack and execution on CPU, GPU, NPU, while other applications often use PyTorch, GGUF, or ONNX-based models natively. So what this block does, it starts open OVMC exe with our model folder under the model repository path, exports the REST API on default port 8000 and sets the job type to text generation for an LLM. And target device, select CPU or GPU. The cache directory points OVMC to cache directly points OVMC to a cache directory. Tool parser, it's Qwen3-Coder. OVMC uses this to interpret two function call output from the model in the format used by Qwen3-Coder. For v3 chat completions, this allows the server to parse two calls like JSON or special tokens in a way that matches Qwen3-Coder style agents. If you use different model family, you would change tool parser to whatever OVMC supports for that model. For example, Hermes 3, Llama 3, or Mistral. Qwen3-Coder is the correct match for the Qwen3-Coder OpenVINO model in our script. I will show how the model is downloaded. When you run the batch file, if the OpenVINO model isn't in the expected folder yet, no OpenVINO model XML, Skip downloads it from Hugging Face, then starts OpenVINO model server. If the model is already there, it skips the download and only starts the server. So in this case, model is there, model is available, and we can start the server. So you can see that server is starting, no downloads. I stopped it and I will rename the model folder. I will start it again. So this time you can see it's downloading the model, and when it's finished, it will start the server. If we go to the release page, we will see files OVMC Windows Python on zip and OVMC Windows Python off zip files. OVMC Windows Python on is the OVMC build that ships with OpenVINO model servers Python integration enabled. Python backed pieces inside the server, which is not your project's Python. While Python off is lighter, binary only style package. With the Python off build, you mostly get plain back and forth chat. The model replies in text, while with Python on, the server can handle tool calls so the model can invoke actions such as run commands, touch files, use IDE tools instead of only describing what to do. While continue, the Visual Studio open source AI code agent, which we will explore, needs Python on. Continue is built around OpenAI style chat plus tools for editing and agents that needs working full function calling, which lines up with the OMC Windows Python on package, not the slim Python of build, where the path is often missing or unreliable. Let's start the OMC server and open Postman. V3 in the URL is the API version plugin used for OpenVINO model server or its OpenAI style REST interface, for example, V3 chat completions. Clients set their base URL to V3, so requests are routed to this version API instead of OpenJS v1. This time we are using the OVMC version that includes the Python folder. I'm sending a request that should call the tool, and you can see the tool call in the response. So the tool call. Now I'm stopping the server. Replacing OMC with the version that doesn't include Python support. Starting the server. You see the response, it says I need to call the weather tool for Paris, but I don't have access to the actual tool execution environment. The tool call is empty. The continue Visual Studio open source AI coding agent requires working tool function calling. So we are using the Python enables Python on build. First we install Visual Studio Code. Then open the extensions, search for continue. Select Continue Open Source AI Code Agent and install it. Open Settings, then Configs, then Local Config. To continue, config YAML is your main configuration file. It tells continue which AI models to use, how to call them, and what context to attach to prompts. So typically it defines models. It's a models provider, for example, OpenAI compatible base URL, model ID, API key handling, default like context length, and max tokens, and roles like chat edit, autocomplete, etc. Capabilities, whether tool use is expected for that model, auto autocomplete options, open limits, depends, timeouts, etc. For for the context, which context providers are enabled, like pod, terminal, docs, div. So continue knows what to pull into the prompt. Continue reads this so the same editor can talk to local servers like your OMC v3 or cloud APIs with consistent behavior. Your project's config YAML is a portable example of that setup for the local OpenVINO path. The context length is how many tokens continue assumes the model can use as input. System plus messages plus context. It determines how much history and context continue will try to include before filming should match or stay under what Qwen3 OVMS actually supports. This number is 64K token style window, which is large code-based chats if the backend really allows it. Max tokens 4096 is the upper bound on new tokens generated in one replay. Completion length. It limits how long each answer can be so responses don't run unbounded. 4096 is common cap for coding answers. If you click on models, now you will see that the model has been detected. Under the tools section, some options require confirmation, ask first, while others do not, which can be changed. Let's start the server. And now I'm prompting create Next.js 14 project in the current folder using TypeScript and Bootstrap 5, etc. Generally, I try to use Bootstrap instead of standard Tailwind and CN libraries that mostly come as default libraries when Next.js project is created, to see how Qwen will handle it. So I'm selecting the agent mode, but you can choose plan it initially and then implement it. So each time we need to click accept to proceed. If you go tools section and change the option from ask first to automatic for some entries, then you will not be forced to click accept each time. But I will leave it as it is and will click accept each time. is my GPU usage. So the project is created. I will show some continued features and other feature to our project. Let's try show code actors. Extract the constant in enclosing scope. Extract inner function in function home. Extract function in module scope. Let's select code and Control L. And now I can type change loading to loading. So now I can either reject or accept. So I'm going to prompt create bootstrap navigation bar with sign in link in the top right corner that opens model login form with fields for username and password. On the project's main page, display random images using the Pixam API. Organize the generated files into their respective folders.